this.
Hello. In this video, I'll talk to you about variable transformation. Specifically, we'll look at how you can make the raw data you get more usable for analysis. So we can examine a bit about data transformations, how to create new variables, aggregations, hierarchy, set and parameter, and how those interact, and finally, table calculations. To get us started, variables seldom come in a format that we want them to be in. One may be interested in a combination of variables, such as knowing as percentage rather than the raw numbers. One may be interested in knowing not about profit or sales, but the ratio of profit to sales. One may be interested in just the month from the date field. The variables may not be in the desirable form, in the right format that they're wanted in. In order to make them relevant, one needs to transform the data. This might take two forms. One may be to create new variables or new columns in the data, or it might involve rolling up the data, in other words, aggregating or summarizing the data. We'll be looking at each one of these types of transformations. Okay, let's begin with the first kind, which is about how to create a new variable or variables from our existing data. If you think about your data as a large spreadsheet, this involves adding new columns of data. So we're going to look at here how to create a new variable from measure, create a new string variable, transforming a numeric variable, making a numeric variable categorical. Then we'll go on to looking at how to create a new categorical variable from a dimension. We'll examine how to get numerical variables from date and time, and finally how to combine levels of a dimension. All these will be examined through the lens of Tableau, and almost all of them involve using the calculated field option within Tableau. Let's begin with some basic calculations. So in order to do a calculation in Tableau, one has got to use the calculated field window. This is where one inputs simple formulae or uses built-in functions that come with Tableau. You can find the calculated field option from either the data source tab or the worksheet tab. Let's take a look at this in Tableau. Here's my Tableau screen. We will make use of the sample superstore dataset to illustrate all these different variable transformations. So I'll begin by clicking on the sample superstore dataset in the bottom left-hand corner of the blue ribbon on the start page. If you missed that, you can go back to the start page by clicking on the top left-hand corner, visiting the blue ribbon, clicking on sample superstore from saved data sources. I'm going to go back now by clicking on the start page again to the data source, the worksheet view. I'm going to go back to the data source window first, so I can show you where you can go to create a new, where the calculated field option resides on the data source pane. If you hover your mouse pointer around any of these variables, or any of the columns of your spreadsheet view in the data source window, you'll see an option called Create Calculated Field. If you click on that, it's going to pull up a window where you can plug in your formula or utilize a built-in function. We will make use of this through the worksheet view. So for now, I'm going to close this window, click on Sheet 1 to go to the worksheet view. Once in the worksheet view, I'm going to first reorganize my variables so that they're grouped by folder, not by data source. This is a personal preference. Now, when I look on the left, I see dimensions and measures organized and separated by a fine gray line. In order to create our calculated fields again, we can go to either the caret option up here or from the down arrow next to any one of our variables. Okay, Let's go in back into the slides to see exactly what we'll be examining as we navigate through these different options. To get us going, we're going to look at a very simple transformation, how to create a numeric variable from a measure. As an example, we're going to perform two computations out here. One is going to involve creating a profit after tax variable, and the other is going to involve a log transform version of sales. So our goal here is to go from what's on the left to what's on the right. Let's first build that template that we can look at the data from before we go to the after option. This might require a bit of work to create the table, but it will help us kind of view very nicely and easily how variables are transformed within this nice tabular view. For this, I'm going to go over to Tableau, and let's create this simple table first. So this table involves having on the rows the year. So I'll drag order date to rows, and order date is treated as discrete by default, fortunately for me, and therefore it's the years showing up here. Next, I'll drag. I want to get columns of different measures. So to do that, I'm going to drag measure names over to the columns, which is going to show me, a placeholder for measure names, because at this point it doesn't know what measure names to use. Next, I'll drag measure values over to text to display all the measures available. We don't want all the measures for our view. We only want 3 of them. So I'm going to filter out the measures we don't want by dragging measure names over to filters. Under filters, I can go and specify what measures I don't want, like I only want discount, profit, and sales. I'll click apply now and OK. And finally, I'll do a few cleanups here. I'll make this year go away by hiding the field labels for rows, and then I'll expand this view a little bit. Well, let's do a few more things. So let's make sure our discount is set to average discount. It isn't meaningful to add up discount percentages. Now, discount is a percentage, so let me go and format that. Now, there's a couple of ways to format your data. What I'm going to do is I'm going to go to discount on the left and change the formatting of discount by default to be percentage. You can find this under default properties and then navigate to number format. We're going to specify a percentage format. 2 decimal places sounds appropriate, so I'll leave it at that and hit OK. There you have it. Now I'll do the same thing with profit and sales also. First, for profit, I'm going to go to calculated field to create, default properties. And from there, I'm going to select number format and choose currency custom with no decimal places. I'll repeat this for sales. Because I'm doing this at the default level, it affects every level of profit and sales I'm going to use, including the fields in the measures values card. There you have it. We now have a view that has average discount, profit, and sales. I feel it's implied or implicit that the discount is average. So I'm going to simply make that, alias that to say just discount. Okay, there's our view. It's ready to go. Okay, now this is our let me call this our simple table, right? Okay, simple table is a way to put it. Okay, and next, well, I'll copy this table over by duplicating it. In this duplicated table, I'm going to create the variables we want to generate. We want to create 2 variables here. One is profit after tax variable, which is going to make a simplistic assumption of a flat tax of 10%. So let's do that. So we'll go to profit and look for the create calculated field option. Now, here, when you click on this, you'll see a window pop up where you can specify the math you want to perform on profit. Now, generally speaking, you want to specify a level of aggregation here. Now, think about it. if you're going to use sum profit, if you only have one observation, it's the same as profit, right? However, if your level of aggregation is different, you've specified sum. If you don't do that, and your level of aggregation is different from being at the lowest level, you might run into an error. I'm going to say sum profit out here, and say times 0.9, which is the same as saying, you know, a 10% tax. So profit minus profit times 0.1, well, the same thing as saying sum profit times 0.9. So this is our profit after, and I'll label it as such. Okay. Now I'm going to move profit after tax over to the measures value shelf. I can move it over here, drag and drop here, or I could uncheck the box, or sorry, check the box under filter for the new variable created. But right now, I'll go with the simple, easy option of dragging it over to right after profit under measure values, and that's going to show up in the table above as a profit after tax. Now, because profit after tax doesn't have default formatting specified, it's going to go with, you know, well, it does have default formatting specified, which is a number, but it's not what we want it to be. So I'm going to go and specify this to be under the default properties again, to be currency dollars. Okay, that's done. Next, I'm going to find a value of sales that I can transform. So I can locate sales out here. So let's create calculated field. Here, I'm going to select, find the log option now. I want to do logarithm of sales. Now, there's many versions of log available based on the base you decide to utilize. So if you want to use log to the base E, you'll use ln, or it's called natural log of sales. However, the one that you learn in school typically is log to the base 10, also represented by simply log. Now you can find the functions available to do math by looking under the number option on the right. If you don't see this, all you've got to do is expand this, click on this caret out here, and it creates that menu. It shows you the menu on the right. So now under number, I'm going to look for something that looks like log. Now there's two options of log here, ln and log. Now with log, I have the ability to do ln as well. Okay, it's kind of odd, but log is a more flexible function where it has this syntax where you enter the value and the base. If you omit the base, it assumes the base to be 10. So let's go with log sales, and I'm not going to mention the base, so it's going to assume it to be 10. Okay, I'll say okay now, and now I have my variable created called log sales. I'll drag log sales over to right after sales, and now it is appearing in, I'm sorry, I made a mistake. So let me go and fix that. It should have been log of some sales, not just log sales. So let me go and edit this value here. So edit the log sales value and say log of some sales, right? And there you go. There you have it. So log of some sales. And now as soon as I make that change, I'm seeing a lot of errors, flags all over. So let me drag this out of here and try that one more time now. Drag log sales over to the right, and now it works. Now log sales is in like log units. So I'm going to, get some decimals here. Instead of changing the default properties, this time I'll change the properties in the log sales pill. It only means that when I make changes in the log sales pill, it only applies to this particular pill, not to every other pill I create from the variables list. I'm going to go to format and select from numbers that I want this to be currency in decimals. Okay, so now we have log sales specified. I don't even know if I should say currency anymore, but let's just say number custom. Okay, or we'll say currency. It's fine. Okay, so here we have it. Let me expand this column a little bit so it looks like everything's in one line. Looks nicer that way. Okay, there we have it. So now we have a simple table, and this table contains our numeric variables, right? So we've created some numeric variables from a measure in this example. Okay, yeah. All right, so let's move along now to other things we can do with our data. So you already know then you can do simple math with your variables to convert them to another form like a log function, or you can do arithmetic like times 0.9, you can do addition, and so on and so forth to create calculated fields from existing measures. Now, there's a lot more you can do with other data formats also. So it might not seem natural, but you can do calculation with string variables too. After all, if something is a string, you could extract components of it, like the first letter, the last letter. You can find out if that keyword contains a certain phrase or word. You can also chop it up into pieces, like by using a function like split. So what we're going to do at this stage is we're going to take our existing data and do a couple of things with it. We're going to split up the data using a delimiter and extract its components. So in our data, we have a variable called customer name. Now, it might be interesting, or somebody might want to just split up the customer name into first name and last name, right? So if they want to household their data, for example, they want to find out, well, who's part of the same family. Now, there's no guarantee that two people with last name Smith are related. However, if you match them up across other variables, also like address, you could maybe make a guess that the first people are related. Okay, in any event, there could be many applications of this task, or maybe just for data hygiene purposes, the company wants to split up the name into first name and last name because it's better to have them in, because then you can sort by last name if it is split up in different columns. Okay, so let me go over to Tableau now, and we are going to now, first things first, create a little table of just customer names and sales. So customer name, and I'll drag sales over to the text, text on the marks card. When I do that, the ABCs are going to turn into sales. Okay, notice they're all marked with a $sign because we changed the default properties of sales to dollars. The next thing I want to do here is split up customer name into first name and last name. To do that, we need to split up customer name into two parts. Now, notice something about these names. If you scroll down these names, you'll notice a couple of things about these names. So, well, some of them are kind of interesting ones, like Anna Haberlin. I can't pronounce that. I guess it's got the two dots on top of the A, so not it has a UTF-8 character there, not one of the characters on the keyboard. Ms. O'Donnell has a the apostrophe there, and so on. And there are likely to be some people here with a middle name as well, which might create some challenges for us. So one simple thing we could do is we could say, split these into first name and last name. Okay, I'm already seeing a problem here. So Corey Locke, notice Corey Locke has a hyphen. I don't know what to do with that, right? That might present a problem for us as well. Okay, let's see what we can do then, okay? And then there's also the issue of people with a middle name. What do we do with those people? We split, if we were to split the name up into, based on the space, we would get three names if some person has a middle name. So we're going to go to customer name and see if we can address these issues. So I'll say create calculated field. And here I'm going to say, okay, this is going to be defined as our first name. So I'm going to call this first name. And now let's look for a function that we can apply to string variables. It should be under string. So let's select string from here, which accumulates all the string functions. So in here, you can look for an ASCII value, car, contains, ends with, find, and so on. lower, lots of things you can do here. If you want to parse this using regular expressions, you can do that as well within Tableau. So pretty powerful. And then there's one option here called split. Let's look at the split function. So the split function works like this, as the example shows. You can split A, B, C, D using the hyphen and specifying 2 to extract the second, element in this A, B, C, D expression. So our name, now, if he applies to our name, we could probably say the same thing. We could specify delimiter as a space and say we want the first value. Okay. If I say this, let's see what happens. So basically we're saying, give me the first name after you split the name along the delimiter. Drag first name over to rows to examine it. And here we have it. Looks good, huh? Okay. Now, see if it worked for Corey or not. Didn't work for Corey. Let me see if I can do something else here. What if I say delimiter is, I wonder if it'll let me do an or. Okay, so say or, it's a hyphen. Let me do that or not. We'll see. I don't think it's letting me do that. Okay, but I'm not going to try that. Okay, so yeah. Yeah, it's not letting me split using. Now, another option I have available is I could examine here something called regular expressions, which is where you can specify some cryptic way of teaching the computer the syntax, like A to Z would mean. So in this, illustration out here, A to Z in square brackets means letters, plus means more than one letter. So if there's a family of letters, A to Z in square brackets plus indicates a word. \S plus indicates one or more spaces, and so on. So that's a way to teach a computer about, language. So, and that's called regular expressions. But we're getting too deep in the weeds here, so I'm going to kind of get away back off from that, and we'll just kind of deal with the fact that we haven't quite been able to parse Corey Locke correctly because full name or his or her full name here. Now, the next thing we want to do here is we want to gather together all the last names. So we can go back into and create another calculated field, or I'm going to try and edit this first name field. I'll say edit. And now if I edit this thing, of course, my first name will be lost. So I'm going to call this last name. This way, my formula is still intact. Now, there are a couple of things we can do out here. One option is we can simply say 2, which should give us the word after the delimiter. This would work in all cases with just 2-word names. What if somebody's got a middle name? Well, then it's going to give you the middle name. So, you don't know whether to say 2 or 3 here. They have a middle name, you want to say 3. They have 2 middle names, 4, and so on. It turns out Tableau's got a very, very cute little method of dealing with this issue. So you can simply say -1 here. So -1 tells Tableau to start counting from the back instead of the end instead of the beginning. And so with this option, I can say okay, and now I have last names also all these people. Oh, I lost the first name. Uh-oh, I lost the first name. Let me go back and reclaim that first name of mine. That didn't work out so well. So I'm going to make a copy this time, or duplicate this variable, and then edit it, not do what I did last time. Okay. So here I'm duplicating that variable first name instead of like editing it, right? Last time I was trying to be cute with that option. And notice I can always specify spaces also here. So why not just do that? Looks nicer. And this time I'll go and remember to say -1 out here and okay. All right, so last name's on there. And let me split up first name also into have a space by saying edit here and putting a space between first and name. And there we have it. We now have first names and last names for all our customers. Well, we have some, it's not perfect because, the Corys of the world are kind of not represented well here. it seems to work for pretty much everybody I can see. I've listed out here, including ones with, odd names like Bueller, the U with a two dots on top there, and so on. Okay, it's also working with somebody with an apostrophe in their name. There's a data point called sample company A. I don't know what that means really, but notice had this been a person with 3 names, middle name also, it would have picked up the last name correctly. Okay. All right. So we've learned how to split a name. Now let's give it a name. So we're kind of splitting. I call this, extracting name, first name. Okay. And then we're going to go on and try and extract. Let's see. We should use a better term. Let's say, the string, something that's generic, right? So think of a name more less generic than string from a dimension, right? Okay, so digits of order ID is what we're gonna do next, and this was basically first name. So name, okay. All right. Now, our next task is to take order ID. And if you look order ID carefully enough, you'll notice order ID is this cryptic expression. It's got CA in the beginning, which I assume means California. And the next block probably is the year. And then there are some digits after that, which I believe are the actual number, which would be unique for that year and state. Let's complete the table up putting cells in here. Okay. Next, what I'm going to do is I'm going to want to chop this up to extract just the digits. So we can do that by going to order ID. Notice order ID here, even though it's an alphanumeric expression, is really being treated as a string variable. So as before, we'll go to create and select calculated field. And from there, I'm going to specify split again. Okay. We'll say split, and our delimiter here is a dash or hyphen. So we'll say that and then say we want the third component, or we could say -1, that either one would work. We'll change the default name from calculation 1 to order digits. Okay, that's good enough. And now we can put order digits right next to order ID. We can see we've extracted the digits of every order in our list. I'm going to eyeball this data, make sure that it's working well for, at least a couple of cases that I can eyeball. It seems like it's working okay, I think. Although I don't really get the, I'm getting a feeling that the prefix in the beginning, CA, is not California, but Canada, and US is the United States. Okay. So I got that wrong. Okay. All right, moving along. Let's go on now to examining how you can make a numeric variable binary. Now, there are scenarios where this might be relevant. Now, for the most part, you don't want to take numeric variables, convert them to binary, because you're losing a lot of information. You're losing variance to the variable when you dichotomize a continuous or numeric variable. But there are some instances when this can be handy within the Tableau environment. Let's take a look at one of those examples, one of those kind of use cases. So we're going to go over to Tableau again, and we're going to make a numeric variable binary. So it'll be generic here. Numeric variable to binary. Okay. Binary. Okay. And binary means your variable is going to be a kind of a high-low, true-false type variable. So what we're going to do here is we're going to take our customer names, make a simple customer name sales table first. Okay. And now we're going to actually create another variable, which is going to be a marker variable. So we're going to use sales and transform sales into one that's a marker variable. So look for sales, and the marker variable is 1, which is going to identify our premium customers, right? So let's say customers with sales plus sales of more than $10,000. So I'll mark them here as, well, the sales is more than $10,000, so greater than 10,000. Now, when you provide, a computer something like, a greater than, less than, or equal to sign, what you're telling the computer to do is to give you a result. The result is a logical. In other words, if the number is more than 10,000, that would be deemed as being true. Less than 10,000 as being false. So you get basically a true or false result from this, or a logical or Boolean. Or in other words, a binary variable. Hit OK now. Here's a new variable called sales 10K plus. Notice it's true, false. Now, I'm going to put sales 10K plus onto color. Now, realize sales 10K plus can only take two values. Let's take a look at them before we go on for you. Everything here is going to be either true or false. It doesn't show as values here, but trust me on this, they're all going to be true or false values. See, let's see them. So here, I'll drag it over to the right, you'll see they're all either true or false. Now, let's do more than just drag this onto rows. Let's try and put this onto color and see what happens. If I put this in color now, see, what's happened is that all the numbers have gotten color-coded, which can be really handy. If you're looking for a needle in a haystack, it would be nice if the needle fluoresces or lights up. Okay, that's what we're doing here. So if I click on color now, I can also specify useful colors. So I want the needle to shine and everything else to fade into the background. So I'm going to go to here, Tableau 20 color palette, gives me more options, and then make the true to be some color like green, let's say, easy, catchy color. And everything else I want to go into fade in the background. So I'll make that like, oops, I'll make the true green. Okay. And the false, I'll make some other color like light faded color that's going to, disappear in the background. I could pick a gray or something if I wanted to, but let's pick a Seattle gray from here. I'll pick a really gray. There you go. Okay. So I picked a light gray color out there. So you can see now what's happened is that you can see if you're eyeballing the data, that your Adrian Barton is standing out and his numbers are standing out because of this little tool we've used. So you can really kind of highlight some information by using a binary or logical here we have. All right, so we could also do another kind of transformation. So when we've already seen here is this one here. We can go one step further and say, well, what if you want to convert something into 3, 4, 5 levels? Okay, so if we do, customer sales more than 10,000, we get either it is true or it's not. So you've kind of dichotomized the variable. What if you want to convert something into 3 or more levels? Well, then your option could be a sequence of logical statements or greater than, less than options, or you could use a case statement, or you can use an if then else if type chain of expressions. So here's the default, the generic if else kind of statement. It looks like if something, then something, else if, then, and so on. So some of these are optional, like the else is optional. And that's it. Yeah. So let's go on to implementing this, putting this into practice. What we're going to be doing here is we're going to be dividing our customers into 3 tiers. So those who have sales that are above 10,000, 10,000, those below $1,000. So if you kind of review the syntax out here, which I'll type up in Tableau, you'll notice we'll be able to create customer tiers, splitting our customers into 3 parts. All right, so as before, we're going to go into sales, and I'm going to say create calculated field. And I'll say here, these are our customer tiers. So we have 3 customer tiers. Those that are gold, silver, and bronze. So I can say something like if a certain condition is met, which is some sales is greater than some number, like let's say 10,000. Or I can say, let's say less than 1,000 to be consistent with what I have in the slides here. So if some sales is less than 10,000, right? Then notice there's a prompt showing up here. And so you can either use lowercase or uppercase out here, but Tableau wants its functions all to be uppercase. So I'm going to stick with uppercase to make them look consistent with what Tableau wants me to do. All these bronze customers. And then I can say else, but I also want to talk about, yet another level. So I'll say else if instead. Else if, and again, we'll copy some of this syntax to make it easier so we're not being typing stuff repeatedly. Now this is a bit more complex. Say here, less than 10,000. Okay. And so if I now say here 10,000, then what I'm saying is that if somebody's less than 10,000, they'll be a silver. You might be wondering, well, what if they're, $5? Would they then be silver? Well, no, because that condition would have already been met here. So if they're at $10, then they're already classified as bronze. You wouldn't go to the next line of code. You just end right there. Now, if somebody is not less than thousands, when you go to the next line of code, you'll examine, okay, are they under 10,000? Well, then they're silver. If they fail that condition as well, then we'll say else if, and again, we'll copy some code syntax here. And well, when they're more than or equal to 10,000, I'll say then gold. And now it's showing me a red line saying, okay, which means he just wants me to kind of do something more. It's saying, okay, I got an end statement here to end this off. Okay. Now that's great, but what if there's somebody with no sales data? Then let's say else here, null. Or we can say else not categorized, something like that. Okay. Okay, that's it. And this is it. Hit OK. And we have a customer tiers now. Now let's create that little table so we can examine the tiers in action. So I'll drag customer name over to rows and sales over to text as before. And then this time we'll put customer tiers on color. Okay. Now we're going to get 3 colors. Let's make sure the colors are appropriately, the tiers are appropriately colored. So I'll make gold to be, I'm going to go top of 20. And I'll choose, green for gold, because gold is like really valuable to customers. And then I'm going to make silver to be something less prominent. So I'll go with this orange, or bronze I'll make like some gray color, because bronze customers aren't as valuable. So apply. Okay. So now you can see as we navigate through this data, you can see the green popping out, right, drawing your attention more so than the orange, and the grays kind of fade into the background. Okay, so that's yet another way of kind of highlighting elements of your data, as we talked about. Okay, so let me go over now to, go back to our slide and kind of see where we're going to go next with this. So next thing we'll be doing is converting numeric variable to categorical. So yet another case where there are some situations where you want to categorize your numeric variable if you want to, say, examine the distribution of your data. So let's see how this is done. So I'm sure you've heard about histograms in school, so I won't bore you much with the details of this kind of. We're going to walk through a process of creating a histogram, though, so you can kind of see the process by which we are going through to generate this histogram. Okay, so we want to make a histogram of sales. Now, to make a histogram, one has to first generate a frequency distribution. A frequency distribution essentially is putting your data into neat, discrete ranges. So let me, to that end, be able to see our data. So what I'm going to do here is I'll create a duplicate value of sales. And this value, I'm going to convert into dimension. Right? You would probably be thinking, why would you want to make sales a dimension? Oh, just bear with me here. I'm only doing this to expose all the raw numbers. As you well know, if you drag sales over to text, for example, you'll see a rolled up version of sales because Tableau will by default try to aggregate a measure. However, when you try to move a dimension to text like sales, it is going to show the data as is. Right there you have it. So we have here a lot of marks showing up. Every single mark you have is all showing up right here in front of you. Okay, our next step then is going to be, let's try and see how we could categorize this. So as you can see, there's, numbers we could put ranges, maybe 0 to 100, 100 to 200, and so on and so forth. Essentially, we want to create a binned variable. So we'll go into sales here, and Tableau is a nice option here to create a binned variable. And this is very common. Most programs have a way to kind of bin a variable. So there's functions like in the language R, there's a function called cut, and another function called cut2, which you can use to bin your variable into groups. So same thing here too. Create bins will very quickly help us create a variable called sales bin. I'm going to define every bin to be, let's say, $1,000. You could, of course, change this. Tableau came up with a default 400 something to make sure that we get, equally sized bins or approximately equally sized bins. I'm going to say OK out here. And this is going to give us basically a sales bin variable now. Notice next to it is histogram, meaning Tableau is saying you probably want to use this to construct a histogram at some point in time. Before we go there, let's examine the thinking behind a frequency distribution. If I drag sales bin over to rows, you can see now that you can see the various bins, 1,000, 2,000, 3,000, so on and so forth. And within every bin, you can see the numbers. They don't quite look right, actually. Let me move this up to columns to see it more clearly. So what we should be seeing out here in sales bin right now is the various sets of numbers we created going into different bins. And lastly, we're going to create a bar chart out of this thing by counting the various values of the variable we created. So I'll go and say here, you're going to basically count out all these values to create our chart. Right. So here you have it now. You can see that we have a bar chart containing a count of all the values in every bin. And so here they are. So you can see, for example, there are 9,724 values of sales showing up in the bin under 1,000, meaning most of the sales are like at the low end. And then you got the next one up here, 329, and so on. It all adds up to a total of 10,194 transactions or values of sales. Okay, so that's how you could, bin your variable to then ultimately get a histogram out of it. So moving along, we're going to go in and now look at something else, the case statement. Now, there are scenarios where a case statement is popular. Excel won't let you do it, but many languages will let you do a case statement. A case statement is handy if your if, then, else, if, is getting to be really long, then the case statement is more efficient. It has the following syntax to it. Specify the case, and then the when, then type option, and then else, and finish it off. Here, what we're going to do is we're going to take a categorical variable, and we're going to convert dimension to a categorical variable. So one of the variables we have in our data set is called region. Region has 4 values: central, east, south, and west. What if you want to simply assign some sort of value to each region? So central as something, so on. In this case, let's say we want to assign every region to a regional office. Okay, so regional corporate office is going to be called, Chicago office for central, New York office for east, and so on and so forth. So let me just copy this syntax from here, and we'll run over to Tableau and try to put this into practice. Here we're going to make a categorical variable out of a dimension, right? So we're going to categorical variable dimension. Say regional, I'm not sure. Categorical variable from a dimension. Or basically you could say we're trying to show up a case statement in a way. Okay, so we're going to go to region, which is under location, and create a calculated field there. And here I'm just going to paste in this whole syntax we got. There we go. We'll call this regional corporate office. You can see here, regional corporate office. And okay. Now, as you know, region looks like this. You can have, let's say, region, let's just drag sales over region so you can see the overall sales of every region. And let's put some sales, there you go. And now you want to also say, let me figure out which office should get credit for this job. So I'm going to drag regional corporate office over right next to region. So now get this look like this. So we have the following table containing information about region, regional corporate office, and also the overall sales for those individual regions. All right, moving along now. And so you can of course also see this when you look at expand your data into another view. Let's just do this one actually. So let's just say you've got these different regions, and so you want to the view you can get of this thing benefit of this is that you could be looking at your state, and every state has a region also assigned to it. Every state is part of a region. Let's just drag sales over here too. And maybe you also want to include here the regional corporate office information. So, okay, Alabama, you're reporting to so-and-so regional corporate office because you're in so-and-so region. So you have that information showing up here in the following table. I'm going to show the regional corporate office. I'll just type this regional corporate office. Okay, moving along. Let's take a look now. Let's turn our attention to date and time. Now, Tableau did an amazing job automatically working with dates and times. When you provide just the year, it will assign a value of January 1st to the month and date to complete the date syntax or date format. And in general, it's just fantastic at handling dates and times. What we're going to do here is do something more with dates. With date and time, you can in fact do things like comparison. A common task that I do in my day-to-day work is doing a date diff. For example, I want to find out the time, date, how many hours have passed between two events, let's say, or how many seconds, how many milliseconds, or years, so on and so forth. So a date diff is available in Tableau as well as many other programs. We're going to use a date diff out here to do a simple kind of computation out here. Our goal here is to figure out how much is the average processing time for each region, let's say. And then we'll also add in, just to kind of show off how date add works, we'll add in another thing called average order plus 3, ship date. So we'll add in 3 days on top of the, we'll add 3 days to the average order date, and then we'll subtract the ship date from that, right? So interesting little thing we'll do here. And the motivation behind that is we want to, we want to do another little bit of date computation. The main reason, of course, is to show off what you can do with date. So the date, right? So I'll drag region over to rows, and then we'll drag. We want to get order date in to play. Here's our order date. Okay, we want the order date literally there, so that is not what we want to do. Let me do a calc with order date first, and so I'm going to find out the difference between order date and ship date. Because I'm doing a date calculation, I can find the date function under date, the list of functions. And date diff is a function that pops up right here. Now, if you say date diff, it specify two dates and the units, the date part, month that is, or whatever day, so on. You'll get the difference. So let's try date diff. It says date diff is the following syntax: date diff, order date, and make it a ship date. So you just drag and drop ship date in here, start typing, and get the tab completion going. And then I missed something. I forgot to mention date part at the start. So the date part is going to be day, okay? And there you go. That should be sufficient. I can also say hour, by the way, get hours. And so this is going to be average or shipping time. Processing. So order processing. Okay. There you go. I'll drag this over to the right here and or on text, and bingo, you get the order processing. Let's make up another on the average. So let's get the average here. Now, what if you also want to get maybe some other value like, you know, the difference plus 3 or something. So order date minus ship date plus 3 or something. So you can always go back here and say order processing time, edit this thing. Let's say, whoop, wait, actually, you know what? Don't edit that. Made a mistake before. I'll duplicate this thing and then edit it. Edit. And we'll now say this is average per, we call this, you know, time plus 3 or something. Minus 3. Okay. To kind of see that, we can basically be saying it should be about 3 days. We're going to allow 3 days so we can figure out if people are, if any regions are below par, above par, if 3s are, you know, our ballpark estimate of how much time it should take to process an order. So I can just do minus 3 out here because we already have this in day format, right? So I can say, okay, and that's it. This should do it for me. And I can drag this over to the shelf out here. But the problem with this would be the numbers show up one below the other. So I'm going to leverage the measure names, measure values framework to better represent my data. Let's see right now, it's going to get better. Measure names, filter out the measures we don't want, only keep these 2. Okay. And lastly, I'm going to all the measures to be average. I'm going to make this average for all the measure values. It saves me the trouble of doing it individually for every variable. And there we have it. Okay. So let's take a look at a few more things out here. So one thing is, you know, sometimes you might want to combine levels of dimension into fewer levels. Like let's say you gather data on age and there's very few people in one of the groups of age and you want to combine them. Let's say you gave people the option of marital status, said married, single, married, and then divorced, widowed, separated, on a break, whatever. You think you get the idea. You figure out very few people say they're separated. So you want to pool in separated with divorced, widowed, and so on. That might be one way of, you know, reducing number of levels of your data. So we're going to do something similar out here. We're going to say, you know, levels, we're going to group our levels, right? So we can group our levels into fewer levels. So we're going to do this with our data here. So for example, if you feel like certain levels fit within a larger subgroup, you can kind of create that category. So for instance, maybe you find that you can look at the cities in New Jersey. the state I am from, and categorize them into different parts of Jersey. So North Jersey, Central Jersey, South Jersey, let's say. We'll do that next. So let's take a look at the data and see what these cities are first. So I'm going to click on here. What we're going to do here is we're going to combine the level of the dimension. Okay. What we do here is we're going to drag in levels of a dimension. So where are levels of a dimension? We're looking at here, we have city. We'll drag city over to rows, and you see like a lot of cities showing up here. Okay, that's a lot to process. So I'll drag state over to filters. We just want to look at New Jersey. So I'm going to select here New Jersey and then say only select New Jersey. Right. Okay. Now you see all the states and cities in New Jersey. And there's a couple of options right now. I could select, cities like Atlantic City and so on and say, and select the paperclip next to this. That would create a group of these variables. So then Atlantic City and Bayonne would go in one group within the dimension city. Now, you can also do this visually. Instead of doing this kind of, going through a list like this, we can do this visually with a map. So you may not know where a certain city is in New Jersey. So then how would you, say whether it's in what section of New Jersey it is in? So let's do it visually. I'm going to kind of go ahead and pull in a map here. So I'll double click here on city. And what that will do is it'll pull up all the cities in New Jersey that are in our data. So here we are. Scale this down a little bit and make sure you can see this. Okay. Okay, so if you look at this map, you can very easily tell just by looking at this, it looks like these are all like North Jersey. That looks like Central Jersey. You should logically think about the state, right? If you're going to chop up the state into parts, this would be your Central Jersey and so on. One way of looking at it. And that's what we can do. Simplistic assumption out here of Jersey having 3 parts. So now I could select these cities one by one using control in a Windows or command in a Mac. And look for the paperclip icon. Alternatively, you can try and draw a rectangle around these cities that look to be in the north. And when you release that mouse, your left key on your mouse, you'll look for the paperclip icon. And there you have it. I'm going to click that and say, it gives me an option for city, state. I'm going to say city, state, province. Yeah, I select that one option. And now up on the right-hand corner, it says Bayonne is one group. Great. I'll go on and do this twice one more time with the city in the middle. Again, draw a rectangle around it, and then look for the paperclip icon. And then yet again for the bottom 3 cities. And put the paperclip on that. Great. So you can see right now in the up in the top right-hand corner is a variable created, or rather these different levels been created. What you may not have noted is this little visual thing we just did created for us a nice little paperclip icon variable here, a group variable. So I can just make this all map go away because I don't need the map anymore. So what I'm going to do is I'm going to say, okay, wipe the map clean. I don't even need this. So clear sheet, gone. It's all gone. It's not really all gone because all the information we need is in this variable here. So I'll say edit group. And now you can see in the group, we have Atlantic City and so on. I'm going to right click on that, say this is South Jersey, because I know Atlantic City is in South Jersey. And then Bayonne, I know, is in North Jersey. And Lakewood and so on, there's only one city there. It's in Central Jersey. Now there's another block here because our data has information on many cities that are not in Jersey, and they're all listed down here. So the other section is fine. We'll leave it just the way it is. It's fine. Okay. Now, what you can do, we have created a variable now that enables us to examine sales by not just city in New Jersey, So as before, I'm going to create a little filter for New Jersey and expose the cities in New Jersey. We can now look at profit in these different cities instead of sales, change it up a little bit. And I can see these cities some are more profitable than others, great. Now what we can do is we can group this and say this, okay, I'm gonna group this up like this. I'm gonna drag in city, country, region, state, and drop it right next to this thing. So now I can see, for instance, and I'm gonna actually do a manual sort here because I want North Jersey to be on top. So I'll say sort this manually, we haven't done that before, manually, so that North Jersey's on top. It just makes sense to me. Okay. And here we have the numbers. And then I can also say sort city by, based on the sales, profit, sorry, my bad. So profit, here we have it. So we here have North Jersey on top, then Central Jersey, and South Jersey. And within any given region, you can see the sales amounts. Let me relabel this to be, rename this to be regions of New Jersey. Okay, there we have it. Great. So now we're able to view our data broken out by, we created some subcategories within our categories within New Jersey here. Okay. Right, there we are. And so that's all about creating variables. Let's take a peek at one more topic here in aggregations, and then I'll put the rest for later. So aggregations look at how to summarize or roll up your data. You may recall that Tableau quite naturally will roll up or aggregate any variable that is a measure, which is great, right? By default, we'll do a sum aggregation. What if you want to know more about, well, the mean, the median, the variance, so on? Well, there's a neat little option called a summary card that I think is great when it comes to getting an overview of your data. So let's do this. We'll go into back to Tableau. We'll create an aggregation here. So to do this, I'm going to drag sales over to the marks card, details. And now I can ask for a summary card. But if I ask for a summary card, I won't get anything. So let's see where the summary card is first. It's in the top of your screen. Right? So if I click on that summary card now, I can click on that down arrow and then say, show me summary card. And bingo, you see summary card on the right. Okay. I mean, if you can't see that, it's because the show me thing is covering it. And as we've discussed before, the show me should never be on your screen. Okay, so in the summary card are some numbers listed, and you can get more numbers like standard deviation, so on, like first quartile and third quartile, skewness, kurtosis, so on and so forth, right? And I'll expand the view a little bit. But something odd about this, one of them is, the thing is that, first of all, it couldn't compute standard deviation, skewness, kurtosis, and all the other numbers are the same. That's because the count is 1. At this stage, you've given Tableau nothing to work with. You're talking about working with the entire data rolled up into one number, sum cells. We have to specify what is the level of aggregation. So how granular is the data? Is it by row 1, by individual rows, or is it by customers? Let's say it's by customers, so I'll drag customer name to rows. As soon as I do that, now Tableau recognizes we have 800 rows of data, because there are 800 customers in our data. And now your aggregations are more meaningful. I'll repeat this for profit and let's say discount. Maybe do it for quantity also. How about that? I'll convert discount to average. Well, that doesn't matter. I'll leave discount the way it is for now. Okay. It's getting kind of crowded on my screen though. But okay, get the idea. Okay, so here are all the numbers. Then you can kind of see here we have different summaries showing up on the right, which neatly give you some high level kind of numbers about various things. Discount's not making a whole lot of sense with the average and so on, but I'm going to drop discount altogether. It's just not meaningful here. Okay, so here we have a couple of these nice summary statistics showing up for sales, profit, and quantity. Okay. So we've looked at a whole bunch of different ways of creating more columns of data and looked at aggregations at the very, very tail end of this session. Okay. I'm hoping I hope this session was helpful and you're on your way to being able to transform your variables for use in Tableau. Thank you so much.